Welcome to day 3 or week 3. This is the asynchronous lecture for GIS 414 in winter 2025. It may still be posted after winter 2025 for reference if necessary for students who miss class to see the lecture. On the screen, you'll see some LiDAR images that were provided in the required reading and viewing. I highly recommend that you go to each of the links that are provided on the Canvas pages to view Radiohead House of Cards, and more specifically, Making of the House of Cards video that are both on YouTube. In addition, there's other required reading and reference material again on the two Canvas pages to help you prepare for the lab 6, and in addition to this lecture. So what you're looking at is some LiDAR images that have been created for a music video. I don't want to give away too much because you'll see it in the video itself, but this is LiDAR being used to create a music video done by Radiohead. And again, there's 2 pages worth of reference material. These are just two of the items on that list. As for map of the day, because we're not in class, I'm going to have a couple. This is a map, I forget when it was from, probably in the 2018 or so. This is kind of a poor map of Saudi Arabia. And you'll notice it has 2 either inset maps or locator maps. I can't tell which, over here in the bottom left-hand corner. And this was published on the BBC website. I don't know if it's still there. The link is provided elsewhere. But I wanted to show you that there are still people out there making horrendous maps. And you folks are already making maps infinitesimally better than this map. The next map, also published by the BBC, I don't really understand what's going on here. Perhaps I'm not familiar with the territory, but we have Jordan, Israel, Gaza, Tel Aviv, West Bank, Jerusalem. There's a world locator map. Then there's this. I can't tell if this blue line is saying it's from this area or this area down here is what we're looking at up in the top left. I can't tell. So again, another example of poor maps being distributed widely. This is the BBC. That shouldn't be there. And you folks can already build better maps than what people are producing. So I'm very impressed. Keep up the great work. I wanted to share this information. This is technically still day 3. I don't know why it says week 5, but I want to read this. That's really helpful insight, and thanks for sharing the announcement with your students. This was from somebody who emailed me. We had excellent experiences with Alexander and Sadie, who were from the GIS CERT and MSGT programs. You and the other faculty at UW-Tacoma really do an excellent job preparing students for transition into the field, myself included. So it sounds like this was a master's level student that is now hiring people from our programs. The portfolios in particular are a super helpful resource that I think give a leg up to students willing to point to them in their application packets. So this is what I've been saying all along, that your portfolio is going to be what helps get you in the door for the interviews. Telling people you can do something is vastly different than showing them what you can create. So I just thought I'd share that with you. These 2 images are from Lab 6. The buildings, as you can see in gray, are UW-Tacoma buildings. This is a very old shapefile of Tacoma building footprints. you'll be enhancing this building footprint in Lab 6. And we'll also be including height data due to the LiDAR that we have available to us. You can vaguely see the LiDAR in green in these maps. It's green dots with black around the border. So it appears to be all black in some cases. We use the LiDAR to determine the heights of the buildings and also in particular the building footprints. You're going to import this database LiDAR data using the correct coordinate system. In doing so, you're going to right click and remember to use the coordinate system in which the data was collected, and that is State Plane Harn North. It is very important that yes, our maps and our lab is in State Plane Harn South, but this data, the point data down here, was collected in State Plane Harn North. So we need to bring it into Arc Pro in North. I'm going to give you a quick demo of how that works. You'll have the tables imported into your GDB. They're over here. And I've added GDB to the end of them so I remember which ones are in the geodatabase and which ones are not. To import them, it's a simple process of right-clicking, create points from table, XY table to point. Let me bring the window into the viewing area so you can see it. Automatically, the name of the file shows up where you send it, and this will be your geodatabase, pops up. X and Y are added automatically. I added Z just for giggles. And then State Plane Harn North. This is the coordinate system in which you should import them, not south. In addition, very, very, very important point, if you've already set your environments, it is probably stating State Plane Harn South, as this window does right here. It is important that you change that to State Plane North, which I will do now. And go back to parameters. I will double check that it is going to my geodatabase, and then I will click OK. Super important that you set that on the parameters and in the environments. And then after the environments, make sure to go back to the parameters tab and make sure it's going to your geodatabase. When you do so, the points originally in a table, and I'll show you the table. Here's the table, X, Y, and Z. This is the height, X, Y. That's all there is to that data. Those will come in as points, and I'll need to show you in the LiDAR tab. So let's go up here. I'll turn everything off and then turn the LiDAR back on. This is the LiDAR data, and you can barely see the points. There's thousands and thousands of points in this data file, and we'll turn them, the tables, into points. This is, which one are we looking at? This is the bare earth points. You can see some of the buildings underneath. This is the all returns data. So this is everything besides the bare earth. So it's all returns. So height data, building data, etc. And this is what it looks like with the buildings added. Notice there's the former building here. This isn't part of the UW campus, but you can tell how the points are creating that building. And you'll see other buildings around the screen as you enter that data. From there, you're going to interpolate using several spatial analyst functions to bring the points into a raster file. So this is the bare earth all returns raster file, and or vice versa. Anyway, these are the two raster files based on the points using IDW interpolation. Moving forward in the lab, you will use some orthophotos. You'll have 4 2015 orthophotos and then 1 old orthophoto. You'll notice the old orthophoto, as in this case, because the Pinkerton building is here, but Court 17 is missing, as is the University Y. So they're both missing, so we know this is the old ortho. In addition, it doesn't have that great a resolution. It looks fine here, but as we zoom in, it'll be not very clear. And here's the building I was looking at in the LiDAR point data just across from our campus. We can see that building in the point data, even though it's just points. This is an image it's the later image, because we can tell because Court 17, the University Y, a lot more docks down on the waterfront. This is the updated 2015 rasters. There are 4 of them that you will have on your screen to make up this entire image. At some point in the lab, you'll need to create a data table that you'll be using on your paper map. These are some examples of some decent tables that have been submitted in the past, and I just thought I'd show them to you, give credit where credit is due. If they had their name, they were utilized. Students agreed to have their data tables used. The directions are in the lab, how to create a data table, and I just wanted to show you some of the great examples. Please don't make a non-poster worthy data table. We're trying to produce work that is going to be representative of your skills, so you want to use a good looking data table. And if you're working in a group, I suggest you use the best of the best. Whoever created the best data table, utilize that one in your poster when it comes time for cartography. While preparing data for the lab, you'll be projecting some rasters. And in this case, in the directions, I explained that you should batch project your raster. Similar to using code, you are automating a process, so you do not have to project raster for each of the 4 2015 rasters. You're going to project them using the same coordinate system into your geodatabase. They start in one coordinate system, and you're going to put them in the correct coordinate system. I believe they're in State Plane Harn North, and we need them in State Plane Harn South. There's a link on how to batch project in front of you on the screen. You can also find that on your own by Googling or typing it in. Some of the directions are here. To configure a tool to run in batch mode, complete the following steps. Super easy. Follow the steps and complete the batch mode. I'm going to give you a brief example in a moment. The batch raster will complete down the bottom. It'll say completed. It will take a long time, so don't rush it. Don't click along the screen. Don't go to any other websites. Don't stress out your computer. Let it run. You are projecting 4 very large rasters. Here is my project raster in the batch. I have all 4 files. I'm projecting it into south, into my geodatabase, and then I'm renaming all of the files. It states the input coordinate system. Notice that yes, it is in north. Going to Pro, your project raster will look like this. I've just clicked on it and I'm live with this demo, so it might take a moment to come up. It'll start looking like this as you add the files, but it'll end up looking like the one I showed in the previous slide. how to get there is rather simple. Go back to the catalog, analysis, tools. You will look for project raster, enter, and then right click and batch. And complete this screen and next. And then Arc Pro will take you through the next steps. When you get done, you will end up having in your personal toolbox, you've never done this before, but you just created a tool, Batch Project Raster. Now, you could look at this by opening it, or if we go back, you could actually go into edit mode. And what you've just created, it's actually written in Python. This is Model Builder displaying it, but you have actually just built this tool using some of the features of Arc Pro. So in terms of what you've done with Arc Pro thus far, in this lab, I'm going to say no because I don't want to alter it. You've actually utilized Model Builder slightly, and in some ways Python, to automate a task. Rather than doing a project raster 4 times, you've done it in one process by using the batch processing. On the screen, they are tiny. Feel free to zoom in. I believe a control slide will help, or you can zoom in Adobe PDF that you're viewing this in. You'll see some of the files that I've created, and this is my catalog. This happens to be the LiDAR map, not my sandbox. And then in the catalog, I show you some of the files that you create. There are actually quite a few files just in the first couple pages of the lab to get ready to do the analysis. On the middle image, I do have my raw data that I've downloaded. You can see that there. And then on the far right, I have a zoomed in version of some of the data pretty much before any real analysis has been completed. This is the just getting the data ready to utilize in Arc Pro. We can go back to Arc Pro. In my sandbox, you can see the 4 LiDAR files. There's the old LiDAR, so that makes the 5th one. UWT buildings, that's not showing yet because I had it underneath the raster layers. If we turn these all off, I can turn on the old UWT ortho. You can see that buildings are missing. And then once I start adding them, you can see it's the same area, but just much more detail as I add these. The 2015 rasters designated by this 2015, much higher resolution, and that is making them a little bit smaller. So we need about 4 of them to show the same area as the old raster. Once you complete some of the analysis and you go through the processes, you'll end up with a height field for all of the existing buildings in this data set. I'm going back here to show you the data set. Just any slide will work. These are the existing buildings when this was created. You will then ground truth. And as you can tell, there are different buildings between the old building file and the new building file. And so you will need to digitize some new buildings, and you will also need to go out and ground truth and estimate the heights of these buildings, because the LiDAR data doesn't have any data for the buildings due to the date it was collected. So there are additional buildings. Just for example, this is the Court 17 building, I think right behind Pinkerton. Yes, this is the circle turnaround. So this is the Court 17 building that's missing. You'll have to build that. You'll have to build the YMCA or digitize There's also the Milgard building that is missing from this ortho, so you'll have to come up with a way to digitize the building that doesn't even exist. And I'll show you some examples in a minute. So you're going to digitize, and then you're going to add some height data. And you'll actually need to do some ground truthing to figure out, is this building the same height as this building? I may know the height of this building, so is it the same size as this building? Or you can estimate 10, 12 feet per floor. There's a 4-story building. Perhaps this is 40 feet tall. Or however you can decide how tall your buildings are. You don't need the exact heights. Please don't go hanging off any of these buildings with a tape measure or going out and buying any special laser tools to determine the height. Although if you're a golfer, you may be able to use your rangefinder to find the heights. And then this information is going back into your table. Was this row, this building, in the original data set? Yes or no? The original relative building height. So you'll have the height in there. And this data comes from, these values come from the data. So ground truthing. You've learned a little bit about this with Dr. Kelly. Ground truthing is a term coined by John Pickles. And then you're going to create a layer out of these buildings. So you can tell that this building layer is pretty basic. It doesn't even look like there's any of the new buildings added. I guess this is Court 17 and this is the Y, but it's not that clear. This is a very, very basic kind of sea-level building, and there's no height information. So I'm showing you this to you as something you probably don't want to do. This would be the basic of the basic submission, but not worth many points. Moving along, these buildings have height to them. So you're viewing this in a scene so that you can see the heights of the building, and this student even went so far as to label the buildings using a special code, and the code is in the legend that they created. It has the additional buildings. Pinkerton is there, although Pinkerton is much too small. It only looks the height of the road. So it's a building down here, but down below, up on the street up above it, Court Street, I believe. Court and 17th is right here. On Court Street, it's definitely not high enough, but this is better. It's better than the last version. This is another version. This is starting to show some realization of what is actually going on the UW campus. The buildings have height to them. They have a nice abbreviation. There is a building missing. This is the Snoqualmie Library. The Milgard building is missing. Same thing. Some buildings are missing. Feel free to pause if you need to see these further. And then we have probably the best realization or interpretation of the buildings. There are no abbreviations, but all of the buildings are here. You will be creating and exporting this layer package as one of your deliverables. And here's a Milgard showing that the Milgard building is there, some other buildings. This is probably the best data set that was submitted over the past couple years. Very, very nice building. Oh, and there's a couple more just to show you the variations. This one is color coordinated. There's no legend here. Perhaps you can figure out what these colors mean as you're completing the lab. I just want to bring up reference to the original slide, or the very first slide. This is the YouTube video of Radiohead, and then there's another one, the making of the House of Cards. You can see they're talking about it and explaining how they're getting the data. So I encourage you to watch this, and then of course the other information that is provided. Going to Canvas, just want to run through some of your obligations. This is weeks 3 and 4. There's an overview. Zoom and COVID is referenced in week 0. Pro steps are in week 0. This is the PowerPoint that I'm going through right now. I'll upload the updated version in a moment, so it'll be there when you go there. These are the compilation documents, and then we have Lab 6 assignments. Lab 6 write-up, a very mini simple cartography, so it'll look something like this. This is what I expect for your mini cartography, so very, very basic, 11 by 17, and the idea is that you'll use this not at the end, so this is at the end of the lab when all of these are done, but you'll create something very similar to use for your ground truthing, and that's where you'll go out and make edits, probably on paper or on a tablet, of what data you're going to add into Arc Pro to figure out the heights of all the buildings on UW-T campus. Here's the layer package that you'll submit at the end of the lab. And then next week we will start the cartography. So we'll work again in the cartography clinic for Lab 6 in groups of 1, 2, or 3. You'll be doing that in the design software. That'll be the 22 by 34 or 34 by 22. And then the final print cartography. There is one bonus for the batch project raster tool image bonus. Let me just open that up and show you. All you need is a document, a docx, so Word doc, showing me your batch project raster tool within your personal toolbox, and then an image of what it looks like when you start the process. Ideally, you'll have it with all of your information included. In this case, none of my information is included here, so as to not give away the correct answer. Although I did show you previously in this PowerPoint, and it is also in the slides, the correct information entered into the batch project raster if you need a hint. Last but not least, if you have questions, please feel free to go to the discussions and go to the Lab 6 discussion, and then notify me that you posted. There it is, Lab 6. Notified me that you posted, and then I will definitely reply there. We're using the discussion more than in 311 and 312 because it opens up accessibility to other folks. Lots of times I'll get multiple questions regarding the same issue. This will help all students. If you have a question, they'll be able to see the question and perhaps may help them before they even need to ask the question themselves. I think the last thing I would like to remind you of, there is 1 day left on the course card survey. Please don't lose that 1 point. Also, feel free to submit interesting maps of the week. We'll try to go over those on the next day that we have in-person class. Preparation work for the next lab will be provided. This is the learning plan for Model Builder, which we're going over in the next lab. That would be Lab 7. That's a couple, 2.5 weeks out or so. But just wanted to mention that's in the module for your, if you get ahead and would like to check it out. So this concludes day 3 of GIS 414. This was recorded for winter 2025, although it still may be viewable as a resource for later sections, perhaps in 2026 and beyond. I look forward to seeing what you produce in Lab 6.